It's now 2:30 in the morning. Roughly every 5 days or so, my hard disk on my laptop fills up. Remember, I'm filming in high definition, and so about 10 minutes of filming is more than a gigabyte of RAM, of memory. So I download from the camera to the desktop because I have to process it before I send it off to YouTube. And because it's gigabytes, my hard disk sooner or later fills up, and then I have to kill that film. But I can't just do that willy-nilly. I have to be very careful. I have to check that that what I've uploaded to YouTube is actually correct. I haven't made stupid mistakes like in the sequence of the videos, the clips. So I have to go to YouTube and my website, and I click on one after the other in the order, and actually check that what comes up as stored on YouTube is actually correct. And it's a painstaking, time-consuming process. And I just have to go through this every 4, 5, 6 days or so when my hard disk fills up. And that's what happened. I usually film 4 sessions per day. I did 3, and then I ran out of memory on the camera. So I wanted to download one and then delete it on the camera, but I couldn't download it because my laptop had filled up. So then I had to check through all this YouTube stuff, and it takes hours. And so here it is now, 2:30, and I'd like to finish the 4th session, so it's done. So a fresh start tomorrow. I'm going to have a whole new board. So the ongoing saga of I hope there will be soon other professors, especially retired professors, who will feel inspired by what I'm doing and do the same in their specialties, so that higher education, or education in general at all levels, becomes effectively free. Now, if you're a dentist or a doctor or something, then you have to get hands-on experience in some centralized institution. So that kind of education I don't think will change much from traditional classroom type education. But pad and pencil type specialties, like mathematical physics, certainly pure mathematics and stuff like that, that could be taught via the internet. So that's what I'm trying to do, and I could save hundreds of millions of parents huge amounts of money that they're currently spending on classroom education, which for many subjects is not needed. So I'm fully conscious of what a revolution this is. I just wish more people would see the same. It's just going to take time, I think, years probably. Anyway, okay, so I'll sit on the other chair. So we're in the process. We have five examples of proving that these five languages, none of them are regular languages. You cannot find a DFA, deterministic finite automaton, that recognizes it, because the languages demand more memory, effectively infinite amount of memory, so they just cannot be finite. So therefore they can't be recognized by a DFA. And the second example of a language that we're trying to prove is not regular. We called it capital C. It was a set of strings W, and W has the property, by the way, the alphabet is binary, 2 symbols are 0 and 1, and these strings W, they have an equal number of zeros and ones in them. Okay, that's the property you describe the set with, describe the language. Okay, now similarly, now there's a bit of a repeat. We talked about this towards the end of the last session, but I needed this as a lead-in to continue on this current last session of the board. So we'll use the pumping lemma to prove that C is not regular. Okay, in a proof by contradiction. So that's all pretty much the same as the previous example. Okay, so it's by contradiction. So we assume this language. We assume the opposite. We start with the opposite of what we're trying to prove, and we're trying to prove that C is not regular. So starting with the opposite of that, obviously we assume then that language C, big C, capital C, is regular, right? And let little p be the pumping length that's given by the pumping lever, and so just and as in the previous example, that was example 1.73 in the text. So let the string S, let it take the form 0 to the p, 1 to the p. In other words, p zeros in a row followed by p ones in a row. Right? So all the zeros on the left side and all the ones are on the right side. And there are p zeros and p ones, so that string S, obviously, there's equal number of zeros as ones. Therefore, that string S is a member of big C, because it satisfies the property that there's an equal number of zeros and ones. Right. Okay. Now, so S, the string S, does belong to language C. Now, obviously, the size of S, the number of characters, or the number of symbols in the string will be 2p, p zeros and p ones. So obviously, 2p its length. So 2p is greater than p. So the size of S is greater than p. Okay. Now, assuming that C is regular, and the size of S is greater than p, in other words, larger than the pumping length, then we're forced to conclude via the pumping lemma that S, that string S, can be split, right, into three substrings, x, y, and z. Okay. So for any I, integer I, greater or equal to 0, that string, and now we're getting on. Now we can get on to our current board. Okay. That string here, pumped, so with I greater or equal to 0, so x, y to the I, z, will also belong to the language C. That's condition 1 of the pumping lemma, right? You're starting to get familiar with this. We've been through it a few times now. Okay, now we're trying to show that this is impossible. And just the same sort of thing we were doing before. But there's a problem, and this is why we're talking this second example, which is very similar to the first one, but there's something different, and that's what's happening now. The difference between this example and the previous one. And so we want to show that doing this, pumped string, pumping it means making it longer by having multiple copies of this middle part, y, I copies of it, right? And we want to show that that's impossible, meaning it cannot belong to C. But the problem is, it is possible, is emphasized. And how to do that? Well, one way is to let the x and the z both be the empty string, the epsilon, the empty string, and to let y be 0 to the p, 1 to the p, right? So that means your string then will be this to the I. And by doing that, your y to the I will always have an equal number of zeros and ones. And therefore this belongs to your C. So it's looking as though this here can be pumped. Right? That's the impression. By the special case when you let x and z be the empty string, epsilon. Right? Okay. Now I've said this earlier, but remember there's three conditions in the pumping lemma. The third one is that so the length of the xy part, the first two parts of your string, the xy, those two substrings concatenated, xy, so the length of xy has got to be less or equal to p. Now this bringing this in, your string s has to satisfy this condition, and it's this third condition that that allows you to show that your candidate s, the string, which is of the form, what did we say it was? 0 to the p, 1 to the p. Okay? In fact, cannot be pumped because this condition is not met. Right? Now, you only to find a counterexample, you only need one or more. Well, you only need one minimum, but it's sufficient. Just one of those. If one of those conditions is not satisfied, well, you got yourself a counter example. Right? All right. So this third restriction, condition 3, makes it easier. You can show that this candidate string s, 0 to p, 1 to p, cannot be pumped. Okay. Now,